All right, this is a little lab. If we were in class, we'd do it. It would be quite a bit longer, but online I've shortened it up a little bit. And the purpose of this is to determine that Kepler's third law, see if it applies to planets orbiting stars other than our sun. So Kepler's third law states that the cube of the distances of planets divided by the orbit of the period squared is constant. Okay, that's a whole lot of words, but mathematically it's just this. If r is the radius of the orbit and I cube it, and t is the time to orbit, and I square that, then divide those two numbers, I get a constant. I get the same number every time. And that's what that is saying down here. Find the distance, cube it, find the time, square it, divide the two numbers. You always get the same number. So here it is for the Earth, or sorry, for the sun. And if we're in these units, it's actually pretty easy. The mass of the sun is 1 solar mass, okay? For Earth, the distance is 1 AU, and AU is the distance from the Earth to the sun. And the period, we know it takes 1 year to go around. So I cube the first number, 1 cubed is 1, and I square the second number, 1 squared is 1. And then when I divide, 1 divided by 1, I get 1. So I should find for every planet, since it says a constant, if I do this, I'll get the same value. So here I'm going to do it for Jupiter. So 5.3 is the distance. I'm going to cube that. So, or sorry, 5.2. So 5.2 cubed gives me 140.6. Then I'm going to square 11.86, and I get 140.65. And down here, I'm just going to divide those two numbers. So I'm going to have 140.6 divided by 140.65. And that's going to give me 0.9996. And it says round to the nearest hundredth. So that would actually be 1.00. So it is the same. Now I'll do it for Mercury. Okay, for Mercury, and I'm not going to show all the steps. I'm just going to take 0.39 cubed and put it there. And for 0.39 cubed, 0.0593. 0.0593. And when I do the 0.24 and square it, I get 0.0576. When I divide those out, I get 1.03. So not exactly the same. I had 1 for Earth, I had 1 for Jupiter, and 1.03 for Mercury, but that's pretty constant. And that's what Kepler found for our solar system. Now, he could only do it for our solar system, and it turns out not even for Uranus and Neptune, because they hadn't been discovered yet. Now, we've found lots and lots and lots of planets orbiting lots and lots of other stars, and we're going to see if it works for them. So here's the data for this star, Gliese 876. I have its mass here, okay? And then the names of the planets are just these letters. And I'm going to do the same thing. I'm going to take this number here, 0.021, and I'm going to cube it, put it there. Take this number and square it, put it there. Then divide those two numbers and put it here. I'm going to see if these numbers are all the same. They should be a constant. And then we're going to do it for the second star down here and then answer a couple questions. You can type the values right into this document and then submit it to me for a grade. Thanks.